My name is Engineer Nuraddeen Aisar from MSK Computer Institute. Today our topic is linear graph in mathematics. Linear graphs in mathematics. Last time we've discussed about quadratic graph, where we see how to plot a graph involving quadratic function. So today we will look at a linear graph. So as explained earlier, a linear graph is known as a straight line graph with the characteristic of y equals to mx plus c, where m is the gradient, which is dy by dx, and x is the variable, where c is the constant. Now, let's assume that we have an example which yields y equals to 2x plus 4. Equating this or comparing these two equations, we can easily say that y is y, m is 2, and c is 4. So now, let us go directly into the example. Assume this is our example. Draw the graph of this. Y equals to 2x plus 4. Let's assume we are not given any value of x. You are free to select any value if you like. You can select either from -2 to 5, or from -3 to 4, or from -2 to 2, or whatsoever. Since this is a linear graph, you can take a minimum of 3 points. Join the 3 points together and obtain the solution. Now, let's assume that we take this value from -3 to +4 and see how we can solve this equation or this graph. Now, for you to solve this question, you take the value of x. Since we assume the values of x from -3 to 4 in this case, so here we have x, which is -3, -2, -1, 0, 1, 2, 3, 4. And the same way, you write this value, 2x, and this is +4. Let me draw the table and separate all the x values. And now here will be the new value of y when the x changes. So this is y. The same way with quadratic graphs. When x is -3 here, this is -3. But there is no square in this case. So -3 times 2 will be -6. When x is -2, -2 times 2, -4. When x is -1, -1 times 2 is -2. When x is 0, 0 times 2 is 0. When x is 1, 1 times 2 is 2. When x is 2, 2 times 2 is 4. When x is 3, 3 times 2 is 6. And when x is 4, 4 times 2 is 8. So these values are intact. Now, this is constant value without any variable in it. So transfer all the values here. +4, +4, +4, +4, +4, +4, +4. So the table is completed. Now we can find the value of y. -6 plus 4 is -2, because you are subtracting -6 from 4, because 4 is higher than -6. So you will at least expect -2 to be left. -4 plus 4 is the same as 4 minus 4, which is 0. -2 plus 4 is the same as 4 minus 2, which is 2. 0 plus 4 is 4, 2 plus 4, 6, 4 plus 4, 8, 6 plus 4, 10, and 8 plus 4, 12. So this is the values of y. Now let us summarize the table with the x and y values only. Now, since we want to plot the graph, you are not expected to take all the values because this is a linear graph, a straight line graph. Just select some values and use these values to plot the graph. Now, let me select this one, minus 3, 0, and 3. So I select 3 values. So let me summarize this table with the values I assume. This is minus 3, 0, and 3. When x is minus 3, I have minus 2 as the value of y. And when x is 0, y is 4. And when x is 3, y is 10. Now, this is the table of y equals to 2x plus 4. Now, let's go to the graph to see how we will solve this question using graphical method. Since the question says just draw the graph, so we are not expecting the student to find any solution to this. Just plot the graph. Now let's go to the other side and see how the graph is. Now, as usual, draw the Cartesian plane. That is the x and the y axis. This is plus y and this is minus y. This is plus x and this is minus x. So here we have minus 3 as the least value of x. So let's say here is minus 1, minus 2, minus 3. And this is 0. And the highest value of x is 3. So here we have 1, 2, 3. And now, look at x and y, I mean. The highest value of y here is 10. So, looking at the space you have, you can easily determine what will be the range of values in each successful point. Now, from here to here, let's assume this is 5, 10, this is 15, this is 5, 10, and this is 15. And the lowest value is minus 2. So this is minus 5, minus 10. I believe this will accommodate minus 2. So now we can plot the graph. When x is minus 3, x is minus 3 here, y is minus 2. Since this is y value in the negative direction, and this is 2.5 minus 2.5, so minus 2 will be somewhere here. So now, take this down, and take this down. Where they meet here, you cross and cycle. So this is the point where x is minus 3, y is 2. Minus 2, I mean. When x is 0 here, y is 4. Plus 4, and plus 4 is somewhere here. You cross and circle. And when x is 3, this is the place where x is 3 and y is 10. This is where y is 10. You cross and circle. So if you look at this, this is a straight line graph. Let's see, here we have a straight line graph. From the name, straight line graph, linear graph, or the graph of y equals to mx plus c. Therefore, this is the graph of y equals to 2x plus 4. This is the graph. Now, The students may ask, why is it so that the remaining values are ignored? Well, we are going for break and we will continue shortly after the break. Thanks for watching. Welcome back. Now, looking at the graph, some students may ask, why do we ignore -1, -2, 1, 2, and 4? It is because in a straight line, the higher the numbers, the less neater the graph. For example, if I have line like this, look at how the line is. But if you ignore this, there may be plausible distractors. Since they have the same value of y equals to mx plus c at any point here. So you can select any point and continue. So this is what we call linear graph. Without wasting time, let me explain exponential graph without even giving the example. Mostly the student will easily understand it. Let's go straight and look at the exponential graph. And see how it is slightly different with quadratic graph. Though all of them are curves. We call them curves, but the first one is parabolic. Exponential graph. This is quite different from parabolic. It's not a parabolic, but it is what? It is a curve which starts and increase exponentially. And when we say something increase exponentially, what do we mean? We mean a graph that starts somewhere or from the initial point, which is 0. It starts somewhere here and increase and start increasing exponentially. This is what we call exponential graph. However, this graph is a little bit different from a quadratic graph, which looks like a parabola. If this is a quadratic graph, it looks like this. Let's assume this is a quadratic graph. So if you divide this graph into two, one part of it will be an exponential graph. This is just an assumption. If you have this type of graph and divide it into two, this part may be something like this. So you see, this is an exponential graph. Any graph that increases exponentially is known as an exponential graph. That is why it has the function of x to be, let's say, e to the power of x. Or if you like, you say, let's say, p to the power of x, where p is any value. P is any value. Or let's assume we have y equals to 2 to the power of x. In this case, the function of x is y. Y is the function of x. So p is the same as 2, while x is the variable. In the same way, you can find the value of x, or if the value of x are given, you can easily get the value of y. That is why some people call it a lin function. Lin function. This is lin, or some people call it log, but it is called lin. Let's assume we have the value of x here from -1 to 3. That is, you have only 3 values. The value of x from -1 to 3. Let's see how we can solve this one. Example. Draw the graph of y equals to 2 to the power of x for values of x, or let me put it this way, x less than or equals to -1, and this is 3. For instance, it means the values of x will range from -1 to 3, with -1 and 3 inclusive. That is, we have -1, 0, 1, 2, and 3. These are the values of x. So let's use this one. Let's take this and plot the graph. If these are the values of x, and then here we will have the value of y, and y is equals to 2 to the power of x. Now, if x is -1, this is y to the power of -1, and 2 to the power of -1 is the same thing as 1 over 2. 2 to the power of -1, which is the inverse of negative inverse of this. So, of course, this is 1 over 2, which is 0.5. When x is 0, here we have 2 to the power of 0. And any number to the power of 0 is equals to 1. So this place is 1, of course. And when x is 1 here, we have 2 to the power of 1. And 2 to the power of 1 will, of course, be equals to 2. So here we have 2 to the power of 2. This is 1. And 2 to the power of 2 is 4. Sorry, this is 2. And 2 to the power of 3 will be 8. So the values of y will be 0.5, 1, 2, 4, and 8. So on plotting this graph, you will realize that the graph will be increasing exponentially. Let's look at the graph in this part. Now, let's draw the graph. In y-axis, we have no negative value. So let's start from the base. This is y, and this is x. In x, we only have -1. So this is minus x. And this is the 0 point. So this is -1. And this is 0, 1, 2, and 3. While in y-axis we have 0.5, which is half. So let's say this is 1. Or let's say this is, depend upon the gap that we have, the space we have. Let's say this is 2, 4, 2, 4, 6, and 8. So you can easily divide these lines into 2. So we can say this is 1, 3, 5, and 7. Now, here is 2, 4, are you following? 6, and 8. So when x is -1 here, y is 0.5, and 0.5 is half. When x is 0, y is 1. When x is 1, y is 2. You see, it is increasing exponentially. And when x is 2, y is 4. And when x is 3, y is 8. Now look at the graph. This is what we call exponential graph. The graph of y equals to 2 to the power of x. So looking at this, you can easily identify the graph of y equals to 2 to the power of x, which is an exponential graph. Thanks for watching. See you next.